Hi, this is Pat Moorhead, founder and CEO of Moor Insights Strategy. We are here for the Moor Insights Strategy Data Center Podcast every 2 weeks, whether you want it or not. We're coming at you. So, and what do we do here? I'm joined by my co-hosts, my co-hosts, Paul and Matt. Great to see you guys.
You as well.
Yeah, I miss Will. I mean, he claims to be in Ireland right now in a pub, and he can't dial in for the show or something like that.
I suspect he's in the Hayes County Correctional Facility in Buda, Texas, but he's not letting us know that.
That would be a fun story. And I hear you just get a phone call and nothing else. But hey, if it's your first time to the Moor Insights Strategy Data Center Podcast, we are riffing about data center topics, which are pretty broad. Data center edge, compute, cloud, security, storage, AI, networking, operations, data management, quantum. And we can't fit anything into that cornucopia, but the data center is sexy, the data center is hot, and it is fun. Let's dive in. We've got a lot of topics ahead for you. We're going to talk about AMD's MI300 launch. We're going to be talking about itty bitty models relating to AI. We're talking about Intel Emerald Rapids with 5th gen Xeon. We're talking about AI. AI's got game. By the way, all the creative headlines are Paul.
Yes.
I never had that gene in my body, so I want to appreciate Paul bringing that. Vast Data. Hey, another storage startup every 2 or 3 years. Valuation hits $9 billion. Okay. We're talking about subspace corrections. Has to be a Paul topic because I don't know what it means. I don't understand it, but you will. We all will. And Oracle keeps growing its IaaS, its OCI business with its latest earnings. So, folks, let's jump in. Matt, I am calling your number.
Yes.
What you and I were both in attendance at that event.
Yes.
What magic did
San Jose. Before we start on that, I just want to call something out here. You know, you hit on me frequently for not putting my name in the show notes for like what I'm talking about. It's wholly unnecessary to do that with Paul's headlines. You know what's mine and what's Paul's.
Pretty much. I mean, if it's creative, it's Paul. And if it's kind of like milk toast and fact-based and non-interesting, it's probably yours and mine.
Exactly. So on that like strong endorsement, AMD. So they're back. I shouldn't say back, but they've really stepped up their AI game. As you said, they invited us out to San Jose last week for the launch of their MI300 series accelerators, and there are 2 flavors in there: the X and the A. I'm going to go over these quickly and then give a little bit of color commentary. X is the GPU. MI300X is their GPU, discrete GPU. Sole focus on AI. This is like your beast going up against the NVIDIA H100 GPU. Really strong performance numbers they demonstrated. We'll get into a little bit more on that in a second. But squarely playing in that AI space. The MI300A is their APU, their accelerated processing unit, where they I shouldn't say fuse, but they put CPUs and GPU cores on the same die and give coherent memory and allow for kind of the best of both worlds. So when you look at workloads like HPC and some types of AI training, there is a benefit there. And that's more of a Grace Hopper kind of competitor, not necessarily the H100. So, the MI300, it's the third in their series. AMD a few years back, they focused on getting their CPU strategy right, really nailed it with Ryzen and Epic, kind of found, kind of exit velocity with those, if you will, kind of they're cruising on their own. And Lisa and her team turned their focus to their Instinct series, their GPUs, and launched the 100 and the 200. But the 300 really is significant for a couple of reasons. One, I see it as the first time where AMD has significantly challenged NVIDIA from a performance perspective. Just kind of raw performance, throw benchmarks on one versus the other and how do they compare. That's really important. 2, the timeliness of MI300 is critical. you have cloud companies and customers. I'm hearing 8 to 9 month waits for the H100 to be deployed, right? The cloud market and enterprise is starved for GPU capabilities. So AMD plays a very strong alternative to the H100. The MI300 plays a strong alternative to the H100. Not that it is a second choice, but it is there as a strong alternative. And the other thing is with this, what I see as being broad cloud adoption, we saw a lot of them on stage, Pat. What makes that interesting is the big challenge AMD has had in the past around adoption of its GPU has been kind of the ecosystem, right? Everybody writes in CUDA or uses CUDA, and that kind of locks them into the NVIDIA track. Well, as the cloud folks start to use, by the way, when you're writing in PyTorch, you don't even need CUDA. But when the cloud folks are starting to optimize for the AMD architecture in addition to the NVIDIA architecture, that's all getting contributed back into the open source, which levels the playing field a little bit more and a little bit more for players like AMD and also for players like Intel that are going to come in and other accelerators. So all around, really cool launch. I don't think they're going to be able to make these things fast enough. That's how big the demand is out there. And while I don't think NVIDIA is going to, be toppled with this launch, it's AMD certainly is going to find a strong place in the market.
Yeah, I can't believe the amount of readership that all of us got on this announcement. I mean, on one post on LinkedIn, 110,000 people come in and check it out. And, all in all, I think we've had, a couple 100,000 people tuning into the content between you and I on this announcement. And granted, it was across PC and data center. But what's more compelling than the thought that somebody other than NVIDIA could have something competitive out there? And what really dawned on me, and by the way, as analysts, we always need to watch what we say and how we say it. I personally wrote one of the first white papers on ROCm as an analyst, and ROCm is basically AMD's software. It started off in high performance computing, and with it they won a bunch of national labs work with it. But we should never confuse high performance computing software and that is optimized to for AI training that runs on this. But with ROCm 6, I'm convinced by a few statements that I heard on stage and a couple of things that I've heard back channeled with the IaaS and the SaaS providers, that ROCm 6 is real. And the fact that the guy from Meta got up on stage and actually had anything nice to say about anybody's software that wasn't their own might be the first time I've heard that, right? And Meta being the inventors of PyTorch, right? Meta behind OCP, Meta behind the big llama models, right? For them to say anything nice makes a big difference. AMD threw up this gigantic TAM chart. They moved it, I think they said, from 200 billion to 400 billion in 2024.
That's right.
Now, that's just data center. Okay, so that's GPUs plus ASICs, and AMD gets 10% of that share in 2024. It almost doubles the size of the business. Now, that's too much. I can't even fathom that. Let's say they get 5%. Okay, or that's an additional $20 billion. Okay, and it's just it's mind-boggling at the growth. And Paul, you were knee deep in this when the internet, Web 1.0. I think you worked for either AT&T or WorldCom or MCI at the time. You were building this. I've never seen this craziness, this amount of craziness.
Yeah.
Paul, any thoughts on this AI wave that we're seeing here?
I just one comment here. I don't think NVIDIA was too happy with some of the statements that AMD made in terms of how much much faster it was than the H100s. I think they had to come back.
They actually came out with that post, which we put out there. And what was interesting is the CEO of Grok subtweeted my tweet. Gosh, we sound like we're a bunch of teenagers here. Basically saying, what NVIDIA was doing was benchmarking because AMD optimizes for tokens in and NVIDIA optimizes for tokens out. So anyways, positive news, folks.
Mark knows. So.
Positive news, there's more competition, and competition is good for consumers. It increases innovation, it lowers cost over time, and makes technology more accessible. That is my story, and I am sticking to it, folks. But it's just the truth over time. So, hey, let's jump into our next topic, itty-bitty models. Paul, we all know that there has been a big discussion on, big, huge, multi-trillion parameter models or itty-bitty models, or maybe a little bit of both. So what's going on here?
I mean, we're trying to move to democratization of AI, and we are moving in that direction. AI PCs are helping that out when they come out. We also need some small models to run in that environment without the cloud. Google came out with an AI model that runs on smartphones. It runs on the Pixel 8 Pro. And it's called the Gemini Nano. They had three models, and that's the smallest of it. And it doesn't do a lot. It does, video, adjusts the color and lighting and graininess and stuff like that. And then Microsoft came out with another model that's absolutely astounding in my opinion. It's the Phi 2. They had a Phi 1 and they had a Phi 1.5. But the Phi 2 is a 2.7 billion parameter model, so it's pretty small, but it does some really amazing things. It beat the 7 billion parameter and 13 billion parameter Llama 2 on several important benchmarks. Language understanding and math and coding and stuff like that. But for 2.7 billion parameters, I mean, it's an amazing little model. And, I think we're going to see it maybe get these models even down smaller. They can do such great benchmarking. So I'm really looking forward to it.
Yeah, we're going to see some great stuff showing up on PCs and then to the data center edge with industrial IoT. You're going to need more memory. You're going to need a little bit more storage, but again, this innovation cycle is just completely amazing at how quickly this is moving. And what I think people were afraid a year ago with closed models, we now have some incredible open models out there that are being developed. And I think that's one thing that will keep the innovation going and more people making money than the top 5 tech companies out there. And everybody has to make money to be able to, in the ecosystem, to make it happen. I mean, look at Linux, I think is a great example of democratization and how that really kicked it off. And, Unix was the closed model, right? And then Linux was a lot more open. But no, it's super exciting. We're going to see these on smartphones, right? In Qualcomm's Maui event, they were very clear on how big of a model that they will be bringing to this new generation of smartphones, and then this new generation with Snapdragon Elite X on the desktop. But fun stuff. And thanks, Paul, for bringing that. Let's move to the next topic. We are talking about Emerald Rapids. Wait a second. A lot of rapids going on here. I feel like we just chewed through Sapphire Rapids here. I mean, you were in Portland meeting with Intel. You weren't allowed to tell anybody you were there or what you were doing on it. But what did you learn? I'm not seeing a lot of depth to the analysis, Matt. on this,
Hmm.
and it looks like a Sapphire Rapids that everybody wanted in the first place.
Yeah, so there are a couple of things that Intel did, and there are a few reasons why this is significant. So, and by the way, on the analysis, I agree. I will have something out on the Moor Insights site either today or Monday that gives a deep dive on what Emerald Rapids is. But what Intel did, you're right. We went out there about a week and a half ago, 2 weeks, a few analysts, a couple press folks to kind of get an inside look. And when you look at it on the surface, you go, okay, 64 cores, what exactly did they do, right? But to me, what I think Intel is doing is they are lining up a lot of underlying capabilities within the silicon to make them far more competitive in the next, forget about right now, but the next 2 years, the next 3 years, the next 5 years, as workloads like AI become more prevalent in the enterprise and we move from training to inference. What I think they're doing is they're building out and analytics and all these data-driven kind of applications. What I believe Intel is doing is they're building out a silicon-based infrastructure that will allow for best absolute real-world performance. And that kind of bar where you need a discrete acceleration, they're pushing it further and further to the right with some of the things they're doing architecturally. So, while the billboard is, company A has X amount of cores, company B has, Y amount of cores, and you kind of get caught up in the headlines. I think Intel's saying, let's not worry about that. Let's worry about what's going on in the real world, and let's address the application performance issues that companies are experiencing. So in Sapphire Rapids, they built a bunch of acceleration engines, new acceleration engines into the silicon, things that actually do help with AI to some degree, certainly help with database performance, analytics performance, networking performance. All of these things that kind of add up to application performance, they built in these acceleration engines that CPU can offload to provide greater performance within a TDP that is reasonable. Emerald Rapids kind of builds on top of that. So kind of going along the theme of real world performance, they did things like they went from 4 compute tiles to 2 compute tiles. And without getting into details of what that means or what that is, think about this, right? The more hops you introduce into communication, the longer it takes to communicate from point A to point B. By reducing the number of tiles, they added significant performance to or reduced latency significantly for application performance. That's a big deal. Even though they've only added 4 cores, even though they kind of went to these bigger tiles, they added a bunch more cache. They upgraded IO or they were already upgraded on IO, upgraded their memory and memory speeds. They're looking at, in what, we will call just another Sapphire Rapids. You're actually looking at about a 20% increase in application performance on Emerald Rapids versus Sapphire Rapids. So for these folks that are saying it really didn't do a whole lot, it actually did. And by the way, they're doing it at the same power envelope as Sapphire Rapids. So to me, this is less about, kind of going after the headline, 96, 128, 256 cores. It's less about that. And it's more about deploying or delivering value to those applications that are deployed within your data center. That to me is Emerald Rapids in a nutshell. They did also do some, Intel also introduced some power management capabilities that allows for CPUs that are running at a lower utilization, which most CPUs do in the data center, by the way, down in the 30% range, to be far more power efficient. And they also beefed up their security posture within Xeon. So, on the security side, if you think about what AMD has advertised for some time in secure encrypted virtualization, Intel brought their version of that to market in Xeon. So you'll see that start to show up in the cloud companies just like AMD's does. So to me, there's a lot more underneath Emerald Rapids than just kind of the billboard stuff, right? There's a lot of architectural. And like I said, I think as, you see 2024 roll around in these, and I know they're not going to call it 6th generation, but whatever they call the next generation Xeon come along, and you find that they reach parity with core counts and things of that nature, you're going to find that they have a very compelling value prop because of all of this underlying work they put into supporting everything around those cores, if you will.
So it sounds like there's a lot going on here, and a guy from Zoom got up on stage and talked about how they were using Xeon with integrated AI. And by the way, this shouldn't be a surprise to anybody. I mean, there was a day on with a DEC VAX that every subsystem, which was its own card with a backplane, right? Yeah. And then over time, once we got into this x86 client server era, everything started to get integrated as a chip, not a card. And then over time, it went from a chip on the main board directly into the chip itself. That's right. A great example of this is the math coprocessor, right? Where it used to be its own chip, right? And then it was integrated. That was the SX was the version that didn't have it, and the DX had it integrated. And then we put graphics in there, integrated graphics. We put the memory controller in there. We put in some circumstances a lot of the I/O beyond the memory controller, and then we have SIMD units that would do various acceleration that you could program to, and that was true for MMX. That was true for SSE. With Intel and AMD and everything after that. So it's not surprising at all that I mean, how do we think that Amazon did, hey, you bought this, you might like this. Netflix, hey, you watch this, you might like this. Yep. That was all done on a Xeon or an AMD Opteron or EPIC processor. And the ability to put, again, little blocks on the SoC or on the monolithic die to be able to accelerate that. And you can have the application and be doing the AI at the same time.
That's right.
Okay. So particularly for recommendation engines, right, where you want to have everything loosely coupled over a super high speed bandwidth as opposed to going over PCI Express and having to swap memory back and forth with a GPU. But for industrial strength, hardcore, highest performance training and inference, it ends up being a card. And then with tightly coupled applications where latency is even more important, you get this. So this shouldn't be a surprise to anybody. And I think the key here is that you're only going to have the CSPs and the SaaS providers write to something that they can get on ARM and AMD. And that, right, and it could be, let's say, hey, I support bfloat 16 or something like that, or the latest 8-bit encoding. So, Matt, I appreciate you actually bringing to light what many of the differences are. And I really felt like Emerald Rapids was the Sapphire Rapids that we always wanted. Sapphire Rapids was 2.5 years late. Yeah. And here we are with Emerald Rapids, which to me is kind of the chip that I think Intel wanted in the first place.
Yeah.
Yeah, they're compatible. Emerald Rapids has been compatible with the Sapphire. So
that's right.
Oh, interesting. Yeah, I knew the TDP and the power draw was the same, but I didn't know it was the same socket, and that makes this stuff, super easy. So hey, let's move to the.
I was going to say a little bit more detail on the tile. They went from 4-tile to 2-tile, and each of the tiles have got 2 memory controllers that support DDR. So that there's 2 of them, so that makes 4. They've got 3 PCI controllers, so you got 6 on the chip. They got 2 UPI per tile, which gives you a total of 4, and then 2 accelerator engines. So you got 4 accelerator engines on that. So.
Yeah.
So use the accelerator or not, and UPI is a fast, high bandwidth, low latency connector for everything in the future. So, hey, let's move to the AI Alliance and AI's got game. There's a creative title. We know it's Paul. Paul, what's going on here? Why does AI have game, and what does that have to do with the AI Alliance?
Hey, when you're fighting back, that to me you got a game. That's what this alliance between IBM and Meta have formed. Basically, I think everybody's kind of they're worried about risk in AI, but they're also worried about too much regulation and too many licensing and things like that. It's going to clamp down on the innovation. So this alliance is comprised of is formed just to kind of take care of that and fight back a little bit with that. There's 50 members in this alliance. I mean, it's a global membership. They've got universities, they've got startups, enterprises, and NISC and different organizations. They've got within this alliance. There's about $8 billion worth of R&D funding in there. And if you look at the students that are represented by this alliance, there's about 400,000 students. And in terms of staff, there's about 1 million staff members. So this is pretty large deal. The challenge is that policymakers are focusing on the safety risk of AI, and we really don't want a lot of regulation clamping down on innovation. So that's what this is about. The alliance feels that sacrificing the open ecosystem we've got for AI in the name of safety just kind of clamps down on the benefits that we can get from innovation. So I think it's a good deal, and I'm glad to see that they're doing it. They want open innovation for open source and licensing and toolkits and data sets and standards. So they're looking out for AI and innovation, and what's to become of it.
So I've been very consistent on my feedback on this, and I'll try to maintain that. I'm going to say what nobody's saying out loud. This is an alliance to balance out the equation with NVIDIA and any companies that large companies with proprietary models. Yeah. And it's NVIDIA not only on the hardware, but also related to CUDA and the CUDA libraries and the CUDA models that are there. That's what this is about.
Yeah.
And
it's a big part of it. Yeah. Mm-hmm.
Yeah, the two, again, this is Gen 1, and it's the announcement. Mm-hmm. I'd like to see networking providers in this alliance. Now, there is a low latency Ultra Ethernet consortium on here that AMD did a phenomenal job with a panel where they had Cisco, Arista, and Broadcom. They had Andy Bechtolsheim on stage, like. Whoa! So maybe that's the answer. Maybe it's not. But as NVIDIA moves up the food chain, they feel like they have to control networking because in the end, you're delivering compute performance across multiple clusters and multiple cards, and then clusters of clusters to have a unified memory plane to be able to do the work a little bit a higher performance. So, and the other one, I'd like to see more SaaS providers in there. You did see Oracle, you did see IBM, but nobody ponied up to the bar and said, hey, we're, as a SaaS provider, we support this for our software. I get the infrastructure part, but we didn't see that. And maybe that's coming. And the degree of success of anything like this is going to be what the alliance does, right? Beyond the press release and aside from the 2 PowerPoint presentations, how do they segment the work? How is it measured? Because you know what, folks? I worked for this company called AMD a few years ago, 13 years ago, and the thought was, hey, OpenCL versus CUDA, right? That's the answer. But if you're NVIDIA and you are going at 10x the speed of an industry alliance, you're going to lose, right? So, and if you look at the additive R&D of all those companies, it is phenomenal. And by the way, nothing against NVIDIA. I mean, I would be doing the same thing that they would be doing. I mean, they quite frankly helped create the machine learning wave with, University of Toronto and the money they would donate to universities. And Matt, I don't know if you remember going to the GTCs of the past, right? These boards, that university research projects. And quite frankly, Jensen was trying to find something else to do for a GPU than play games and do visualization on workstations at the time. So, and it went from ML to DL to generative AI, and they built the platforms that all this stuff was built on, and they deserve credit. Now it's like, ooh, right? 52-week lead times or whatever, the 9-month lead times, and I have to write the CUDA. So people just want more choice. And I also think if we're going from 150 billion to 400 or 500 billion dollar TAM increase, everybody can win here. NVIDIA can win. If NVIDIA has 50% market share of a $500 billion TAM, it's like you're going to be rolling in the money. I mean, do the math there. And anyways, I've seen this, we used to play what was called the virtual gorilla at AMD, where we didn't have chipsets, we didn't have graphics at the time. We would work with other people who wanted to make money too. We worked with IBM. So anyways, this is great stuff, and democratizing AI, I put this up there. Matt, we're going to go with an easy one here. Man, does vast data, like every 3 or 4 years, there's like a storage unicorn, although storage companies don't want to be called storage companies. They want to be called data companies.
Right.
And they're not hardware companies, they're software companies. I got it. It's pure storage. No, it's like we're a data company. Vast data, we're a data company. Anyways, what's going on here? $9 billion.
Crazy, right? So they had they announced their series, I think it was last week. Yeah, last week they announced their Series E funding, led by Fidelity Research, and there were a couple of other players in there. And it was 113 million or so in funding they got. And it's interesting, if you read the blog from Jeff Denworth, their CMO, he says it's going to sit in the bank and collect interest, just like our Series B, C, and D funding is.
That's I'm like, man, that's so Jeff. I mean that in a positive way, Jeff. But,
it is unapologetically bold, right? And but they've got it. They've hit it, man. They are that unicorn, And you're right. They don't. I think when I talk to them, they cringe at the kind of suggestion that they're a storage company. And if you look back to their announcements over the summer, their database or their data management platform, they put out their database offering that they've developed and are starting to roll out into the market. They really are trying to go up from the let's just store your data to let's manage this and let's move it around and let's not just on disk, but let's manage this within our own repositories and give you better performance for applications. And it's resonating, the story, because clearly, right? $9 billion valuation. They're in every God blessed 3-letter agency within the U.S. government. The most mission critical, or I should say performance critical applications are running on top of them. They have companies lined up wanting to do partnerships. They're doing something right. So I think they're certainly there's a huge storage element to them, but I see where they want to go from a growth perspective and a kind of adjacency perspective, and it feels like the market's kind of aligned with them, given what we're seeing in this valuation.
Yeah, they look good. They've got $1 billion in cumulative software bookings. They've got 3x year-over-year growth, and they've had positive cash flow for the last 12 quarters. So they're doing something right.
Yeah, and by the way, Vast Data is a data company. Right, what they're doing is they're integrating elements of database that normally is separate and moving it into their stack. They've had just an amazing amount of success in AI. And for those government agencies who want a larger company, they have an alliance. Is it on block storage with HPE, or is it object storage? I forget exactly which one, but there's an alliance there to get larger institutions on board. So,
it's funny because a lot of times you see these startups that they find their niche, right? They solve that problem, and then you see them kind of try and expand up the stack. In some ways, VAST is different, right? Because they are at the largest orgs, and strangely enough, like their partnership with HPE is going to bring them down market, not up market, right? So, I mean, they've done a great job of satisfying those really big deployments. Now they need to figure out a way to serve the masses, or to hit the masses. And I think that's part of what goes behind GreenLake and maybe other partnerships they do in the future. But man, it's an impressive story. Impressive guys over there.
What are they doing globally, Matt?
I'm sorry?
What are they doing globally?
From a sales and marketing, or from they're everywhere. They recently opened up an office in Italy. They're all around Western Europe, Southeast Asia, South America, and of course, North America. You mentioned their bookings and their kind of growth over the last 12 quarters. I had some number, I forget what it is, but even their employees, they're just exploding. They can't hire people fast enough to meet the demand of their customers.
Good stuff, guys. Hey, let's get into a topic I don't think we've hit for the last two shows. Maybe we did. And that's diving back into quantum. Paul, what is subspace correction for constraints?
You want the technical definition? Or?
Where'd I go? There we go.
Yeah, it's basically kind of an offshoot of error correction. Error correction is one of the most important challenges right now in quantum computing. Once we solve error correction, then we're off to the races when we start building, huge quantum machines. And there's a lot of research being done, and this is kind of like error correction in a way. It's qubits can end up getting in the wrong state, and like if you're doing a math problem, you write down a 6 instead of a 9, then that can mess up the entire calculation. You think of subspace correction as if you think of subspace, it's kind of a safe zone where all the qubits can be while the quantum computer is doing all this work. And then if they stray out of that safe zone, then subspace correction is kind of like a smart system. It says, okay, I think I made a mistake and I'll fix it. So basically the steps you have to go through are, you have to watch the qubits, make sure that they're in the right state. If something goes wrong, then the system will detect it and fix it. And it'll determine what kind of mistake it made, and then the system will correct the error. So that process keeps going on and on as the quantum machine goes through all the algorithms and comes up to the final solution. So without substate, this is kind of like a brand new thing. It's very limited in scope, and it was done by Atom Computing, which is a neutral atom computing company. Neutral atoms, the electrons and protons are equal, so it's a neutral body essentially. And their qubits are all arranged in an array. Atom Computing is announcing that they're going to go over 1,200 qubits sometime next year. So they haven't said what their fidelity is going to be or anything like that, but I'm looking forward to having a startup like that going over 1,000 qubits. So it'll be interesting.
Yeah, it's amazing as the generative AI thing blows up. It's like some people kind of forget about quantum, but that's very much not the case. I mean, we're seeing research like this come out from the folks at Atom. I mean, IBM did their huge reveal and put a 10-year roadmap together, right? That, scalability, and it's just crazy, Paul.
Yeah. This is just a, kind of an early study in this type of correction. And they've got some caveats at the end of the study that, they use just a very small sample and they use limited graphs for the study. So, but it's early research, and I think it's important research. And I'm glad to see companies like Atom Computing are publishing research like this now. So.
Oh, it sounds good. Hey, let's move to the final topic here. Oracle quarterly earnings. And reminder, we're industry analysts, not equity analysts. We use earnings as a source of truth, and don't take any of this information as an investment advice. If you follow me, you're probably going to lose a lot of money. So Matt, what's going on here? Is OCI chugging? Looks like they're chugging.
They're chugging just like Intel was. So it feels like I have to have Oracle in every single podcast I'm a part of, and I apologize, but these guys just don't stop moving. I mean, it's pretty incredible how, they're so consistently churning out one thing after another. So yeah, earnings, overall, I think they're up 5% year over year, or something along those lines. Cloud business in general was up, I think, 24% year over year. That includes SaaS, IaaS. But when you look at their infrastructure as a service business, which to me is really the real kind of indicator of how Oracle Cloud infrastructure is doing, 52% growth year over year. 52%. That is absolutely crazy. So for those, and I'm one of the people that talk about Oracle kind of establishing its cloud business through data, because it's a database company and they've got a lot of stickiness, which is true. 52% growth is more than just databases being migrated from on-prem to off-prem, right? That's significant growth. In addition to that, they've opened up a couple new regions, one in Bogota, one down in Chile. I don't know where. They're getting ready to open up some more regions in Southeast Asia. I just, I feel like I have to just draw attention to the fact that this company is, from a growth perspective, a cloud growth perspective, is absolutely, that transformation is on display. And I'm kind of curious as to when they're going to be part of the discussion. Whenever we talk about the big five, the big cloud folks, when Oracle is finally going to be allowed into that club, because while their revenues aren't there yet, their growth certainly is, and the moves they're making set them up to be, and I think give them enough credibility to be a part of the conversation.
Yeah, their percentage growth is amazing, and the value proposition that they're offering to customers and customers picking it up is undisputable at this point. And yeah, I think people are looking in terms of threes, and right now it's AWS, Azure, and Google Cloud. And also depends on how you slice it. Mm-hmm. IaaS, PaaS, and SaaS, right? Yep. I think right now we're looking at IaaS. Companies like Gartner smash IaaS and PaaS together. Yeah. So I think when they hit that revenue number in, they will get a lot more of the respect they deserve. But let's not forget, OCI 1 was not good. OCI 2 was a grounds up architecture, bare metal as its base. And then you can do anything. If it's bare metal, you want to put VMs on it, you want to do containers, you want to do serverless, go for it. And they also put their applications, because some people forget this, but Fusion and NetSuite is some of the largest SaaS software that you can have. That's right. I want to give OCI a plug for the simplest version of hybrid infrastructure. They literally they copy the infrastructure that they have in the public cloud, and they literally deposit it, and they put a chain link fence around it, and they manage it, and you can run any Oracle application on that. And Matt, I hit it on the 6.5 pod this morning, but check out what Google announced. It's right in your wheelhouse with distributed cloud,
Mhm.
which they added 6 new ways you can do on-prem infrastructure.
Huh.
And we don't call it Anthos anymore. It's called the
Right.
Google Distributed Cloud. But it looks pretty compelling. And, the 25% of the data is still on-prem. And the IaaS and PaaS service is slowing as a percent. It's like, and I look at the ARR increase from GreenLake and stuff like TrueScale and Apex. It's like interesting.
Yeah.
That's something. You add colos on top of that, and listen, the business model isn't giving anybody 30 points of omp inc like AWS.
Yeah.
When you take out stock-based compensation, but for these on-prem folks and people who operate, they rather have some cash than none.
Yeah.
And now that we've kind of arrived at as containers as being the vehicle for future applications, and even containerizing the VM, if you want to do kind of lift and shift, yeah, it's game and yeah, go ahead.
Yeah, it's funny you say that, Pat, about the data, because even when you think about, like, if I'm a large enterprise, right, and I've got a huge data warehouse and a huge Oracle presence, or DB2 or SQL Server, really, insert database name here, right? Why would I want to move that up into the cloud, right? This is where, like, the Google, the cloud, Oracle Cloud at customer, or distributed computing from Google, or Outpost. This is where I think these become really interesting value props, right? Because I want to look, as a database administrator or a CIO, I want to offload all of that tedious work I do around managing my data environment, but I don't want it up in the cloud, right? This is a perfect compromise for me, from a cost and kind of agility perspective. And by the way, for Oracle, it begins that kind of migration to the cloud. So I think there's a lot of interesting kind of play in what they're doing. I think over time you're going to find these enterprise organizations find more and more value in these kind of distributed cloud models. Even though they didn't take off yet, or they didn't take off in the past, I think their time is coming. So anyway, my 2 cents.
Oh, it is. And by the way, like in any growing market, it's going to be both, right?
Mm-hmm. Oh yeah.
And AWS has hybrid on-prem. They just don't like to talk about it a lot. They have a lot of very compelling things in between that they do, like AWS local zones. So, for instance, you're a Hollywood movie maker. They built a data center right in Hollywood, a small one. It's not a hyperscaler data center, but it improves latency and egress charges. I'm sure they're doing a deal with them, because sending up video into these massive things and then getting it out could be really expensive under the current terms. AWS also has a special offering with carriers where they'll put their infrastructure on the edge. I think it's called wavelength, or they'll stick them. It's interesting. I heard some of the carriers over the years talking about, yeah, we're putting AWS infrastructure into the core. It's not in the core. It's actually on the edge of the core. And I think it only makes a difference between, it makes a difference just to me from potentially a latency point of view. But interesting stuff. The hybrid multi-cloud is alive and well. 10 years ago, I called it. I got the transport wrong with OpenStack. It wasn't OpenStack. It ended up being containers. The problem with OpenStack is it wasn't necessarily open, and it wasn't in a complete stack, and revisions came out twice a year.
Yeah.
I hit the macro picture. I missed the delivery vehicle. But we don't always get it right at Moor Insights Strategy, but we try hard to get the important stuff right. And I will go to my grave with hybrid multi-cloud fabrics as the new thing going forward. So we'll see how that goes. I hope I'm not in the grave soon, but I'm taking that one there.
We should do tattoos. Do a company out and get tattoos on our shoulders or something.
That is a great idea. And as a leader, I want to defer and let everybody else on the team go first. That didn't make any sense. But hey, it's Friday. We're having fun here. I want to thank everybody for tuning in. I don't have any more business travel. I'm going to be at the CES coming up, I think the second week here in Las Vegas. Yes, the company does do consumer and it does enterprise and data center. You'd be surprised how many enterprise client devices and software get announced at CES. I mean, there isn't any Convex anymore. Where the heck else are you going to announce this, right?
That's right.
Thanks for tuning in, anybody. Take care and have a great Christmas, holidays, whatever you want to call it. Take care.